quick presentation on the flood predictor that we talked about in the previous session. I'll let, as a good faculty practice, I'll let my student start first so that he can take the initial flag and then I'll take over. I would like to call over Sundar. He's a BTech undergrad. He just passed out of Amrita Vishwavidyapeetham Coimbatore campus. He's an aerospace engineer. Yeah, you are an aerospace engineer now. He's got his thing. So he's a man who worked behind and coded this, a large part of it. It's a collaborative project. We'll go into the details. Sundar, please.
Good afternoon, everyone. Sir, I think the best motive behind this is availability for the data, for the availability for the prediction of flood. As you had suggested during the working group panel discussion, I believe, was in the best interest of Dr. Komrat. So he had asked us to work on this, and we have a predictor that can predict if flooding can happen given the amount of rainfall pattern that we know about it. And as of now, we have restricted these studies only to the southern part of India, like majorly towards Kerala and Tamil Nadu side. Plus, one of the major reasons being we need a flood predictor that is exclusively for India because the river flow pattern is different. And then the second thing that we would like to address here is that the soil percolation rate, the amount of rainfall, and what is the surface that remains under the river bed plays a crucial role. Plus, the flow in the water over these regions is highly driven by the slopes of the mountains. So, whereas when we take up the rivers in the North India, they are mostly glacier melt rivers. So this analysis is restricted only to the rivers in the southern part of India. And this is a collaborative effort between Georgia, working group of Dr. Komrat in Georgia Institute of Technology and Amrita Vishwavidyapeetham. So here we take up So the major motivation behind this is the Kerala floods that happened in the year of 2018 and the Chennai floods that happened once in the year of 2015 and that in the year of 2017. And the common link between these two probably serves as the reason why we need a flood predictor like this. So, as we all know, the Kerala gets its monsoon, which is mostly driven by the rainfall is driven by the southwest monsoon, whereas for that of Tamil Nadu, it is the northeast trade winds. So we have the western Ghats that are shown in the picture that intersects the clouds between Kerala and Tamil Nadu, causing heavy rainfall. Like the southwest monsoon clouds are intersected, causing a heavy rainfall in Kerala, leaving the other part in the Tamil Nadu region a little bit dry. Whereas right now, because of the poor management, we have droughts, of course. So we can also, this project is with a hope to see if we can have to extend the study to see if we can have a possible solution for the existing flood and drought case. So the Kerala floods of 2018, as you all know, 35 out of 54 dams were opened at the time in Kerala floods, and such floods were unprecedented. Causing I think in this 1 month's gap, between July and August mid, Kerala received about 116% of the amount of rainfall that it receives annually on an average. Whereas for the whole collective monsoon season in that year, in 2018, when the floods happened, it had an excess of around 40% rainfall. So this excess water was just drained into the Arabian Sea, of course, to reduce the side effects of the drought, of the flood. And similarly, we have floods in Chennai. Again, The floods in Chennai were mostly driven by, I think they say it is because of the El Nino event that happened between the year of 2015, 2014-16 El Nino event. And yes, because of poor management of water resources. And next is the improper settlements, that people actually had the settlement area in the place where the river floods had to flow. It means illegal settlements, essentially. So this is the second time, the 2017 is the second time that Chennai received flood. Yet the scenario is much more alarming because right now, not too far away from the flood, we have a drought. So this is how this is how the Chemberambakam dam looked like a few months back, because we were facing a severe drought because we don't have proper water management. So okay, fine. So Dr. Nandagopan will take on from now.
Right. So we'll just now see some of the results that have come from Professor Comrade's group in Georgia Tech. So they've started off the differences that we are, as we explained in one of the intro slides, we are going for a more CFD, computational fluid dynamics, rigorous based approach. Well, they are doing a more of a pilot study. So he's got an excellent undergrad student who's worked on it, who's ripped apart the code and written a Python code that essentially takes out GIS data and then converts, and you're able to read it. So to cut all this terminology short, is like we have mapping available about our terrain. And that's what people were talking about before also. So the idea is, can we use this openly available data? Can we model how the river actually would flow in the case of a flood? And there's one crucial thing that I would like you to be clear on this. There is a difference between flood prediction and flood modeling. Right? Flood modeling, often what happens is this, we very often see in these Discovery Channel documentaries where people actually show a river overflowing, dams being breached. That's a flood modeling. That is not exactly what we are trying for. We're just trying to have a code that says, well, if rain continues this way, these particular regions are going to have water at this particular height. And obviously, if it's 2 meter height water above ground level, you are flooded. So when is it, or how long does it take for water to reach that danger level? And how much of rainfall are we getting? So this data you take in and predict it out. So this is why we call this as a flood predictor, not a flood modeler, because the methodology would be different in this, in case that a crude method is good enough. We are looking for a cruder method that can take in a larger amount of data and thereby predict the onset of a flood. So they have these results, three-dimensional model. This is like the actual data that they have taken for the terrain over Kerala, and what happens after heavy rainfall. And those color regions that you can see is what happens when the, where is it that rainwater gets accumulated, or where are the high chances. So just to also add in, because there was a gentleman who was mentioning that most of the talk seems to be about Tamil Nadu and Kerala. Well, the problem with rivers, rather the North Indian, the major Ganges as such, Ganga would be, I cannot even think about modeling it, because the sort of terrain that it flows through, the sort of variations that it has, modeling a South Indian river would be much easy. It's a rain-fed river. A glacier-fed river that flows through such a complicated terrain, that would be really this thing. I just wanted to have this clear to you. It is not that we are neglecting out or we are partial to South Indian rivers. South Indian rivers are pretty easy to model, and we are pretty close by, because we are from Coimbatore, and therefore Kerala and Tamil Nadu are obviously points of interest. Right. So what is it that we would want, or what is it that a flood predictor would bring to the table? So, conventional map planning would rely on manual cartography. In plain words, maps that have been prepared. Map making is a very painful, tedious, time-consuming, and requires huge man-hours. So, I think Professor Comrath was presenting in his talk a map from 1982 that is available in the central water, data pool. That is as recent a map as we can get regarding this. That there is a reason for it. The reason being that it is a humongous exercise to undertake. So the alternative suggestion is that when you have technology developing and when you have maps available coordinate-wise, you have very high resolution map. In fact, the data set that was used for this is a pretty crude because we wanted to demonstrate it. Even that had an accuracy of 100 meters. So you are able to distinguish between 2 points that are 100 meters apart, right? And so this would reduce cost and delays associated with preparing the data, and you are getting much more accurate data. And if we are getting it from an agency like the ISRO, we are getting data that is, that has some level of transparency and level of authority behind it, because probably we would have. So the next thing is that how do we go about the big question about interlinking rivers is interlinking of rivers, because people talk about this, the ecological cost and all this thing goes on. But way before talking about that, how does the water actually flow? In case of heavy flooding, how does it flow? Are there natural regions where, so in the previous slide, are there actually regions where there is huge depth which can naturally act as water storage places? Is it enough to connect these two storage points? Is it actually manually link a river? And in case you want to link a river, is it better to do that by bringing a huge canal built and then manually linking it, or is it better to have a small so-called ducts cut off, thousands of those small ducts cut off, and gradually having it together? Because the general move in engineering seems toward distributed systems, because distributed systems have the advantage that they do not fail suddenly. When you have a single large system, you are also increasing the chance of sudden failure. And of course, the real motivation behind this would be that we are the two systems that we talked about, again, the the southern India, where you have Tamil Nadu and Kerala getting rain-fed rivers. There is very good pattern into Indian rainfall, and that is something specific. The monsoon is probably an India-specific phenomenon. I don't know. I see weather people here, people who studied geography and weather, probably Kiran, or you can. Probably, but we have, the predictability is a question, but you have a very specific pattern to this. And secondly, the way that rivers flow, the slopes that they have, and the sort of soil that they have, you want to know how much of water actually flows, how much water that enters the river flows through the river, how much gets leached off, how much gets absorbed by the soil, how much gets evaporated. These are crucial questions to understand, and for this it is better to have India-specific models or even river-specific models rather than having, importing some data. As we talked before, rather than taking crude approximations on a theory, it is better to have, model exactly what you're working on and then start off with that. It will give you a better approximation. So there are huge commercial, if you try flood predictor or flood modeling into Google, Google will tell you Mike flood, Google will tell you flood analysis systems. These are all commercial software that is available. There are two problems with this. The software has been developed for entirely different logic, because many of these software, at least two of these softwares, do exclusively flood modeling, not flood prediction. And you are talking about a very small data set which is given in, and flood modeling based on the altitude height differences is done. We are looking again for something that is more of a flood predictor that can talk about water level heights over a very large area. We can take that data from any of the satellite maps and then predict out what is the probability of water rising above a particular level. Right. There are issues like 2D and 3D modeling, which you again come to. So how much do you want to go into 3D, or how good is a 2D model? These are things that we want to see. And what resolution is good, because if you have data for India on a 1 meter resolution, how are you going to store that data becomes a problem. If you have data on a 1 kilometer resolution, obviously the data is not good enough for doing any of the calculations. So there is a level of optimal data that is required, an optimal resolution that is required, that is good enough for the calculations to work, yet the data is not very fine that you are sitting on top of huge amount of data which you cannot decrypt. Right, so to give a brief overview, the plan now is to stick to a finite difference method. Professor Commoners group, they have started off with this and it's showing very good results. It's going very good very good answers to this. The finite difference method for people who are from the background is probably the crudest method that can be done. But the advantage of this is that it's also the simplest to code for a large data set. And we are not exactly looking for very specific profiles or anything. We are just looking for water level heights. And the methodology would be to get GIS data, satellite data, import that, have a code that is able to read this data, and with a simple FDM formulation, you use this. Ideally, we would like this data to be open source data so that people can see what is happening. And hopefully, we hope to extend this, if this takes off as this way, we would hope to extend this to a level where we can study what happens when you have channel flows through mountains. This is again connected to the interlinking idea. So what happens when you have channel linking across mountains between river systems? And hopefully these are very lofty and very far away goals. So just talking to a very, very futuristic point, hopefully talk about a flood drought curse, a solution to that. Yeah, I think I would stop with that unless and until someone is so interested in seeing equations and technical details, I wouldn't go any further. But as faculty, I feel it customary to include equations and so these things in slides. I'm unable to prepare without them. If not, I think, do we have time for questions? Yeah, if anybody. Yeah, sir, please.
Yamuna Basin, Indus Basin and Brahmaputra Basin, river flow is classified data. River flow is classified data in all these three basins. So therefore, you won't get the numbers you need.
Okay. Right.
It may be classified for Indians to get, but the Indian government has given that to Alphabet Incorporated, which is Google.
Well.
Yes. So today, apparently, there is an effort going on to model floods or predict flood, whatever it is, in Patna. And that is being undertaken by Google Incorporated, using data given by the Indian government. This is an issue that I will mention.
Yeah.
Long ago, maybe 2002, where terrorist attacks were happening in India. And apparently the Indian government came out with a white paper on terrorism, which was given to a select group of media people, very secretly. So we tried to get that. Our Indian citizens tried to get that. They said, no, we cannot give it to you. We can only give it to media people, including foreign media people. And I think similarly, there was a report that came out after the 2004 tsunami about the Indian Navy's contributions to rescuing people there, which was, a tremendous, a matter of great pride. We tried to get a copy of that report. They said, sorry, we cannot give you. I don't know the reasoning for this. I think it works the other way. In most countries, they will give it at least to their citizens and deny it to outsiders. In India, it seems to be that it's easier. If I had applied for that, saying I'm American and asking from America, I bet I would have got it. So anyway, that's a classified part.
No, but I'll just add to this bizarre kind of conundrum that we face. Survey of India, for example, has opened up their cartographic data, digital cartographic data, so they took since last year. But as a citizen of India, so you have to put your Aadhaar number in before you get access to the sheets, the digital sheets. But when you do, you also have to click on and say yes to a form which actually subjects you for that download to the Official Secrets Act. So there are all these strange hurdles that Bharat Sarkar loves to come up with. But the suggestion that I had for you is, you're trying to remove or to mitigate the flood drought curse and to therefore be able to predict floods. What I would suggest to you is to look at it in a slightly different way, which is to check for or to monitor the abuse of watersheds. River basins are divided into sub-basins, which are divided into watersheds. We have, depending on which agency has actually mapped a river basin, there are 3 different kinds. So we have between 100 and 106 or 107 sub-basins. Sub-basin would be a collection of approximately 4 to 8 districts, which is a substantial population. Now, our difficulty is that administratively, a district is also a default water management unit, but a sub-basin or a watershed is not. Administratively, we don't have that. We did have that under the National Rainfed Authorities, but that is largely a toothless organization now. This is one way I feel. If you are able to disaggregate this and run it as a program for a district administration to use, or even an interested panchayat to use, in some way, you translate this so that they don't have to deal with equations, and say that, look, here it is, here's a package in your hands, you can put it on the computer which is sitting in the panchayat office, and somebody who's interested can run it. Then it completely democratizes the forecasting of how water is used at a watershed level, and therefore incorporates what you're saying about the flood prediction. That's what I suggest.
Yeah, that's
I think that is a very useful suggestion there, and we are very happy to do that. Of course, if anybody will give us more detailed data, that would be very helpful. But the hope is exactly to do this, to make whatever is done available at the local level, hopefully on cell phones. And so the idea is that for your region, you have already downloaded the necessary data and done all the calculations to know the relation. What we call influence coefficients in engineering. What is the relationship between what happens over there and what happens over here? This can be done beforehand, once and for all. So you don't have to wait until the rain has started before you do this. So the computation can be done beforehand, and so you know what the situation is for your place. You don't know what it is for over there. So you're not depending on a national level prediction or something like that. We are hoping, I don't know, we are very new at this game, but like many things, you say, why should you do this? There are hundreds of civil engineering departments, there are meteorological departments, there are this department, that department. Why are you doing this duplicating effort? I asked the same question I asked about the village. Why was it that at 8 o'clock at night on one day in Kerala, people went home saying, okay, there's only 3 inches of water, I know it's been raining, no problem. At 10 o'clock, it was 5 feet of water because somebody had opened the dams and not told anybody. So that is a reality, and perhaps there is a room for doing something useful.
I just want to also point out, this standardized precipitation index, which is actually compiled by IMD, that's compiled on a weekly basis. But NRSC, National Remote Sensing Corporation, on a grid which is probably about 50 by 50 kilometers, it's very large, but they do it daily under a program that they called NICES, which the C stands for climate, something to do with climate, but they do it daily. And I'm sure they have finer resolution than what they provide on a website.
Is this data accessible online?
Yes.
They are the people who receive all the remote sensing data and disseminate throughout India all the data. And there are supposed to be regional remote sensing centers in each state that is supposed to be, as a Government of India requirement, each state is supposed to have it. And they are supposed to get the data from NRSC and then further process it for the local requirements. So this is basically in an ISRO-sponsored program, which of course the government is supporting. So you have the data both on all kinds of remote sensing requirements, either agriculture, flooding, rain, disaster, anything you want.
So we hope that, down the line, we hope somebody will pick up on these things and the panchayat can actually, get their
No,
own.
basically what it occurs is you have a sub-basin, you predict for the sub-basin, and then it can be, whatever is required for the district administration can be extracted out of that and given to them.
Yeah,
But
so
then it is natural to treat a sub-basin as a, relevant entity rather than a district as a relevant entity.
So we would like, in other words, the people who are going to suffer the flood should have the ability to do enough calculation at least to then call up and say, hey, what is going on? Or one other thing is to say, look, what is the likelihood that the people operating the dams are going to open the dams?
Look, that is indiscipline. That's a different issue. I don't think we should discuss that.
Yeah.
And you say that you're going to make it very transparent and open to people. But are you going to hand this over, and if so, to who and in what form? That's very important, first. Second, you are not taking into account one crucial factor, perhaps, which is siltation of rivers in Kerala. And the mining that happens, sand mining that happens. That is crucial. In fact, many of these 44 big and small rivers, medium and small rivers, are in disarray because of this illegal sand mining that's happening. So unless you put that within your algorithm, I think the predictions may not be very accurate.
Ma'am, that would be one reason why we want to go for a more GIS satellite-induced mapping, because this wouldn't show up on a conventional, not just the sand mining, there's a lot of illegal settlements that happens close to, so-called resorts that are built. So this wouldn't show up on official maps. It will show as fallow land through which the river flows. There is no river there. That's a problem. So if you want accurate this thing, it's more better to go for a satellite. When I said open data, I meant we would like to use data that is in the open domain.
So who will you hand this over to, and in what form? So a district collector or a tahsildar?
Okay.
Will he be able to know that in 2 hours' time, Kottayam city is going to get 2 feet of water logging?
Being guerrilla types, we are probably not set up to, nobody will take it from us, but I think we would like our families to have the ability to have a sense. This is what I said. Our only goal, as far as I can tell, is that we want to be able to give people the enough calculation ability to say, look, this seems like a good weekend to go and visit our relatives on the other side of the Western Ghats.
Video valuables.
Yes, or move your stuff, furniture to the upper floor or something. And then perhaps with credibility, but to address the issue of the river, realities of the river. I think the only way to do that is to collect local data, okay? And if the government tries to do that, it's a huge exercise. But if thousands college students with cell phones have access to this thing, we can probably put in measurement systems that can calculate these things from actual local conditions. Hang something from a bridge, see the flow rate, and we can figure out how much flow is going through there. So that takes into account the actual ground reality of silting and all these kind of things. To do that, we need public participation.
As per Act, as per law, it's supposed to be done once in 3 years. Sand auditing, it's called.
I think the dam maintenance is also supposed to be done once in, yes. But, we hope that we can get to the point where people are actually using this, and they're collecting data and putting it back into the system, and then we can extract that. So that would be, that's down the line. Hope.
Good work.
Thank you, ma'am. I think it's now time to go to the far out things on thorium technology and hydrogen technology. In whichever order you want to take it, I think both of these are yours.
Yeah, okay.
So I think you should introduce yourself.
Oh, sure, yeah. Well, I started as a student here, about 20 meters from here, and I got my PhD, first low temperature PhD from this institute. And I gave my first talk from this podium something like 43 years ago as a graduate student. A non-profit organization which is International Symposium on Hydrogen and Matter. Okay, I started handling hydrogen right about 20 feet away here from compressor cylinders because that is the medium that is used in the Stirling cycle to generate coal. So that means I am handling hydrogen all my lifetime as a scientist. Then so basically I couldn't find an opportunity to serve India, so I had to go away. I went to Southampton University in England to do postdoc. Then I saw a newspaper announcement there that India is starting a cryogenic program for the launch vehicles. So I wrote a note to Professor Dhawan. And I was surprised actually to get an invitation to join ISRO as a visiting scientist. In that capacity, I started working at VSSC, very close to the director Gauri Shankar's office at that time. And luckily, I was the longest living scientist from outside in the guest house. I forgot the name. Yeah. So one day I was having dinner, and I see Dr. Abdul Kalam, and we struck a conversation at the dining table. And he says, okay, come on, let us continue this discussion. So the discussions with him went on until 10 p.m. that day. So I'm very glad to be here in honoring Abdul Kalam's conference, and Dr. Narayanan was kind enough to include me into this, of course, I was introduced by Ravi's father, Dr. Adarsh Deepak. We have been neighbors for about 33 years, and my son and him went to the same school. Of course, he's a little older than my son, not so much. Well, okay, I joined, I came here, and then I was told, you have to wait for 2 years to start working with us because they have no money. Well, I said, okay, I'm going to a conference in, I think, somewhere in the European countries. And if you are willing to offer me a position to come back that provides air travel, I'm willing to come back. They said, well, no, we can't do that for you. So that was the end of. Then they actually said, your appointment closed after 6 months I left the country. So that was my experience with India. And of course, I never tried to come back. So I was working at University of Southampton, and I did a lot of work with cryogenics and instrumentation and a lot of other stuff. And then I traveled to US, joined a continuous electron beam accelerator facility in Newport News, which is a new DOE lab, which has been named as Jefferson Lab. And of course, I'm a staff scientist there, last 32 years. And as part of my job, I was supposed to work on accelerator-driven systems. This was actually initiated when I came to India in 2006 to IISc Bangalore. The DAE organizations knew of my work, and they invited me to come back. So I had to come back 6 months later because they will get approvals for my visit. And then that led to kind of a 75 trips I made to India on the invitation mostly of my friend, I can call him my friend, Srikumar Banerjee, who also visited me at my home. Well, that is the history. And as a part of that, I'm doing this work. I established something called Virginia Ideas Consortium, which will come up in the next talk. Then I was not allowed to do some of this work. And hydrogen is basically affects the properties of materials very drastically. And also hydrogen we are hydrogenoids. We drink 2 parts of hydrogen with water, that is 2 parts. And hydrogen does, if you want to understand our organ systems, you need to go and do magnetic resonance imaging. So that tells you what is going on. And if you think you have a stress or something, you feel warmth, from my perspective, the hydrogen is concentrated there. That causes heating effects. That's what happens in materials breakdown and all that. A lot of things. I came up with this name, and a friend of mine said, well, I'm so passionate about the hydrogen work, I tried to get an acronym in search of him. So for me, him is nothing but Mahavishnu, which is a proton, which is in the center of the hydrogen atom. And Lakshmi is in the orbital, and the Adisesha is the energy force of the system. And then we forget one thing, the neutron, that's Mahabrahma, one of the Trimurtis, he's supposed to have created the world in fraction of whatever time scale. So I will leave that at this stage, and of course, since I am not allowed to continue the work on accelerator-driven systems, which is of interest for people in India, this is a new director came in, and basically my perspective is he wants to control those aspects of it because I was running it. I created a Virgin Ideas Consortium and a lot of institutions. So as soon as he said that I cannot do that work, I went back to him and I gave him a letter saying I'm going on leave. Take care of it. So that happened as of February 15th of 2017. I'm in my second year. I can get one more year, and by the end of that, I expect to create something in the energy field on my own with collaborators. That's where my focus is. And Dr. Mahendra Shankara, I met him at a conference in December of last year in Amaravati. So he got interested in what I was talking about, and he says, well, you're doing very good work. I said, okay, if that is the case, I'm supposed to give 2 talks here, and I would rather you do this talk so that I can focus on that. And actually, I got this talk from him with some of my inputs only this morning around 8:30. All right, so bear with me, and I will walk you through this. All right, first thing, if you like to see what we are going through in the world in a global scale, clean air and clean water is a problem in India for both of these things. Well, we know in Chennai that's an issue. And when I was living in the campus in 74 here, I had no issues. I take a bus ride to go into city to see a movie, I come back and I'll get headache. This was in 74, and I know what people are going through and all the diseases related to this particulate matter, which is of 2.5 microns. That is about 30 times smaller than the thickness of the air. So that is the matter that is actually affecting the health of the people. You have a lot of lung problems and all that. You go to Delhi, it's impossible to breathe. And I went into China, Beijing, some time ago. I thought that is the worst place. And India, I think they want to be best in everything. I think we are best in polluting the environment we are living in. And we want to compare China, but China has done a good job, and they're cleaning up, but I don't see anything going on in India. And okay, that's my little thing, and that is about air pollution, and this is about water stress, global water stress. I think United States is going to feel this, I think soon, by 2030. I think the humanity is going to be in great trouble with respect to the availability of the clean water. So these two are only possible if we have sustainable clean energy. That is at most. Now, if we don't have clean air, you know what happens. We die very soon. If we don't have water, the next thing. The food comes the third in line. So these are the two fundamental things. It's the people that have access to those things, it is their responsibility to make sure that the humanity has it. Okay, that's all I'm going to say there. Now what I'm going to show you is there are large companies which are trying to, a hydrogen economy in the future. But I got into this way back in early 79. At the time, the US has a problem because of the Arabs have put an embargo on oil, and they said, well, hydrogen economy, they tried to do all that stuff. And then the conditions got better, then they have no interest in doing this, mainly because there is a cheap coal, cheap oil, cheap gas. So United States has no interest in addressing these issues. And I think it falls on two major countries in the world, that is China and India, and China is doing good. They are building a lot of nuclear power plants to replace their dirty coal plants. And I don't know what's happening in India. It's not very clear to me, but it's not in the public view. So this is what a company in Germany is trying to do. And I think since you are here, I'm going to say you are benefiting from this technology. I think this system is installed in Andhra Pradesh. I believe you are getting liquid hydrogen from them. Is it true? Liquid hydrogen? No, I'm not talking about plant. It's a hydrogen generating system. This is German system, which I believe is in Andhra Sugars in Tanuku. So I came to know about this. Actually, I'm going to be visiting them soon so that I can. Basically, my appointment at VSSC was supposed to lead these efforts, but I couldn't. But at least I'm glad it is in Andhra Pradesh, and I'm going to go there and see how can they can help to push the hydrogen economy that I'm talking about. All right, this another company, also similar plans of hydrogen economy. It's not that interesting to read anyway. And hydrogen production technologies, you can see here, near term, that is steam methane, reforming, grid electrolysis, bio-derived liquids, microbial conversion, hybrid and other systems. So if you want to get clean energy, clean hydrogen, my preference will be with electrolysis because that's the most clean. You take hydrogen, you split it, you combine, and you get the energy, either in IC engines or fuel cell or whatever. So this is cost of hydrogen in North America. This should not be of any concern to India. I will give you the reason. These costs are gallon equivalent. It shows about $4, but I think according to Department of Energy, it needs to be below $2 per gallon, then only it will be viable in the US. And of course, as I said, they have cheap stuff, so they are not interested in this. And these figures shouldn't be taken to mind at all. I will give you an example. I just ordered a solar panel system, power system for my house, which is about 6 kilowatts in capacity. That generates enough for me so that I don't draw anything except in the night time. Most of my energy will be created by myself. That gives me a cost of about 0.35 cents per kilowatt hour. That is 24 times than what you are currently paying for your electricity coming from the solar plants, which is about, someone told me about 2 rupees per kilowatt hour. I am paying 24 times that I recoup in 10 years for the system I am just getting installed. So don't ever look at costs related to the Western countries. That makes no sense for India. So you should be deriving all the information for yourself and work out economics locally, nothing to look at somewhere else. And again, pathways of hydrogen production, you can take a look at it later on. And this is most interesting for me to share with you. I read a BBC newspaper, I think it's a video report from someone on a Scottish island. I landed only about 2 months ago. And there are 16 islands in Scotland, north of Scotland. They are away from the mainland. And they had 2 power lines to feed these 16 islands. And they don't have resources. They are depending on imported oil and all that. So fortunately, they were able to make the turbines based on the waves as well as the, tidal energy. They were able to produce so much energy, they don't know what to do because they cannot push it back to the mainland because there are restrictions to put more grid lines there. And so they decided that they would use this excess energy via electrolysis and store hydrogen. And since this is islands, they have a lot of ferry systems. They are actually converting the ferries to run on hydrogen. The first one will be running next year. And this year, they are already modified the existing one, diesel plus hydrogen. So they're actually implementing this, and this report only I got this morning at 8:30 from a friend I met in this island. He sent me, I wondered why it came. I sent it to Dr. Sunkara to include in the presentation. Is there a pointer here that works? No. Okay. So you can see they store the hydrogen. This is going to be at 35 bar. This is for Scottish conditions, so don't worry about it. What India has to do will be totally different from this, because to make it efficient. So they can run cars, vans, lorries, all this stuff, and they can also produce chemical feedstock. Actually, this Andhra Sugars is using the hydrogen they produce from electrolysis to produce some of these pharmaceuticals and so on. And I'm going to visit and see what they're doing. And also heat and power, you can see there. And of course, this is an electrolysis system, and these are very expensive at the moment. The reason they use this is it will give you 35 bar hydrogen that can be directly pushed into cylinders. So that may not be necessary for our conditions. And of course, a lot of automobile companies tried to bring these fuel cell-based cars, but I think they are not going to see the light, mainly because no one knows how long this fuel cell will last. And also, this is very difficult, you can see, the costs involved. So as a result, this is not going to happen, but I am also a consultant on the side, so I came across a Austrian company trying to generate some chemical getters. As part of that collaboration, I ended up collaborating with Magna Steyr, a major car manufacturer in Europe of Canadian origin. And these guys build most expensive vehicles for all automobile companies, like Mercedes, BMW. As part of that, the BMW decided they would use the internal combustion engine rather than the fuel cells route. Actually, they ran this car in 2009. And the basis for that is they use a liquid hydrogen tank at the bottom of the car, and then to take boil-off gas from there and run it through the combustion engine and do that. So basically, I was a consultant to make sure that the insulating vacuum of that container would last for more than 10 years at a pressure of 10 to the minus 5 bar. So I know what is going on in this field personally. So what I'm trying to do is, this is another electrolyzer system. The cost is about $2.5 per kg. A kg is equivalent to about a gallon of hydrogen. As someone said earlier, this is the specific energy for hydrogen is the highest. So this is much more energetic than a gasoline or anything else. So that's something to keep in mind. So I mentioned about Scottish Islands. Actually, they have a gassing station. So you can pump hydrogen into these tanks of the vehicles they modified for this purpose. This is only R&D at this stage. And of course, they produce this either from wind power or the wave or sea power, basically. There is another project that is actually caught my attention about a year ago. I met these guys, and this is an island, French island. I think it's near the Nice. It's spelled as Nice. It's a very nice area in French. There's an island there. There's a university, Corsica Island. They implemented a project where they installed 2 megawatt of solar power, and they use that power to produce hydrogen and oxygen, and then use that to stabilize the grid when the solar power has some ups and downs. So it's a $24 million project. It starts running in 2014, and it's successfully running right now. So this is what their site looks like. Oh, I thought it's 2 megawatts, but it says it's only 560 here. And they have the gas storage here, the electrolyzer, and as you can see, it's it's an island. And these are how the systems looks like in that. Water storage, circulates closed circuit here, and then you have a electrolyzer. This is the hydrogen generator on this island. Of course, this is about half a megawatt system. And the storage tanks are shown here. They are at 35 bar. So I actually wanted to build this at my ancestral site in Andhra Pradesh. I gave a presentation in 2006 for the Institution of Engineers in Hyderabad. It was covered by the press, and actually Hindu also put in a report on that. Now I think we will be able to do this because the solar power costs in India particularly have come down so much compared to 2006. As I said, it's about 2 rupees per kilowatt hour. I think that's so we could actually get these things done and get the hydrogen. Maybe if we want to use the commercial ones, they cost about capital cost 500K. That may be, I think, expensive to import, but I think one could do low pressure systems, except that your tanks will become bigger, and building a tank is not a big deal. So I think this can be really implemented currently in India. It's viable, and this is another example that we could do. University campuses actually can implement this. So they have a lot of solar energy, and they can make hydrogen out of this, and it could be a research activity. A lot of things can be done with this. I mean, if you want to use cars, you can. 2 kg cylinders are readily available. Yeah, basically they store about 2 kg, and anyone, if they are really interested, most of the cities, major cities in India, the taxi cars and all that have to run on CNG. That means these IC engines are ready to, you replace instead of compressed natural gas, you replace with hydrogen. And if they are clever, $50 per kg, 50 rupees per 2 kg cylinders. If people are clever, they could actually go and get them and retrofit. It will work very well. Oh. So can we do solar hydrogen village? I believe it can be done now. Conditions are appropriate, and hopefully we will implement this soon. And main goal here is, I said, clean air and clean water, right? So that means, so the villages can go off the grid completely, and all their local energy needs can be met with the hydrogen they can produce. So villages can show the pathway for cleaner environment in India. It is really possible right now. So this is addressing from the village point of view, and I think my next talk, I don't know, can I follow through that? Yeah, that is, we want to deal with the same situation for cities and towns. And how do we do that is the focus of my next talk. Yeah, this talk is not mine, but well, anyway. Yeah, I can take questions. Well. Go ahead.
So just one question. In the desalination plants that we put up,
yes,
can this be an additional aspect to the desalination plant in terms of taking the hydrogen as part of that process?
If you have energy there locally, the water is already, desalinated water is very good.
Yep.
You can feed into these electrolyzers. I believe it could be done.
Then it would serve multiple purposes, both from a
Yeah,
water supply to Chennai, for example,
Yeah.
and also provide a...
Yeah, power, basically, yeah. Well, but power has to be, now we'll talk about that. Now this talk will cover the power issue. But actually there is a guy in Pune, there is an organization, he showed me a map of India, and then all around the coastline, he wants to build a ship-based HTGR reactors so that he can take the seawater and pump it inland, all from around the coast. So if that is implemented, India could be free from all this, both energy, clean air, clean water. But of course, DAE, Government of India and DAE are like, well, anyway, I don't want to go there.
Can I ask a question on?
Yes.
See, when I think about Scotland, I don't think about, sunlight does not seem to be something.
No, we're not talking solar there. It's wind and
they're
wave.
using wind.
Tidal
Wind
wave
and
and
tidal.
wave.
I see.
Oh, they can power the whole Europe.
I see.
They just started this, and actually the energy available in the sea waves and tidal waves is so much, they can power the whole Europe. It's a slow process, they're just getting their handle on this. Hydrogen economy is a realistic thing.
Yeah.
Why hydrogen economy named by US in 1970s, that's where I started collecting stuff, and they went away. They don't want anyone else to do it. The problem is that.
Have you looked at Iceland? Iceland has been running buses on hydrogen.
Yeah, sure.
But
Yeah.
they're geothermal.
Yeah.
Energy. Okay.
Yeah. But I think Indian conditions are really good for hydrogen economy because you do not have people that will obstruct you like gas guys or coal guys. You don't have enough of those things. So, Mahavishnu. All right, this is thorium energy cycles. As I said, I'm not a nuclear engineer. I'm a low temperature physicist by training. And of course, I'm developing a technology that's of interest to them. Maybe I'll talk about it, I think, in part of this. So as I said, I'm not representing my employer, so I will be in trouble. Legally, I have to disclose that I am on leave, and I cannot use my position in the DOE system. So I make sure that is done here. So I'm representing nonprofit, which is created at Jefferson Lab where I worked. So I am one of the board of directors. It has a couple of Indian top-level people on my board and so around the world. And then Virginia Ideas Consortium consists of Virginia Tech, Virginia Commonwealth University, University of Virginia, ODU, and I am affiliated to all these institutions except UVA. Currently, I'm not affiliated with UVA because originally what happened was when Dr. Srikumar Banerjee came in contact with me, he said, no, we cannot work with the DOE institutional systems. Can you create something with universities? So I was already in position at UVA as a research professor, and I said, okay, I can do that. I spoke to the president of the university. He said, oh, absolutely. He told his provost and do what Ganapati needs. So I was given a position in the provost office, and we actually signed an official MOU. I have some pictures somewhere. I was for that signature, but UVA unfortunately did not have a nuclear engineering program, though they had it in the past. I used it when I went there. So what happened is that old building, reactor building that was decommissioned was given to me so that I can build something there. And I did apply for funding, and the reviews were pretty good. I could not get the money because I'm not a full-time employee of the university. And as a result, that whole program went away. Well, as I said, I made some 75 visits, and then we decided we organize some workshops together. They called initially Indo-US joint workshops on accelerator-driven systems and thorium utilization, and then DOE objected to the bilateral meetings, and they said, well, if you want to do that, it has to be international. So they became international. That's actually came out of Virginia Ideas Consortium, mainly with India keeping in mind. So overview of this talk, introduction to nuclear technology, but I don't know how many people know about how this whole field developed, but I can spend a few minutes if it's not boring to you. And then Homi Bhabha, I think he is a visionary. He studied in England, and also I like to make some nice links here. Homi Bhabha, Sri Vivekananda Swami, and Chicago. There is a connotation here. So Sri Vivekananda Swami was invited to give a talk at a world religious meeting in Chicago. I don't remember the dates, some time ago. And he was traveling in the boat, sea boat. So I think one of the Tatas, is it Jamshedji Tata, was also in that, traveling with him in the ship. And somehow this guy wearing, the colored clothes, and they got struck, conversation. And then Jamshedji Tata, I believe, talked to Vivekananda Swami. I think we need people like you, young people, to educate the future generations. So he created, when Jamshedji Tata came back to India, he created Indian Institute of Science in Bangalore. So the connection here between Homi Bhabha and Indian Institute of Science and Vivekananda follows this way. So Homi Bhabha finished his studies, and he came to India. It's World War II time, I believe, at that time, so he couldn't go back to UK, where he has some affiliations or positions. So he basically joined Indian Institute of Science in theoretical high energy physics. He was actually, he did some great work in the positron electron scattering. It's named Bhabha scattering or something. He's widely known in the world for his work. And then it's in 1944, I think, that time period. So at that time, I think they created another institution in Mumbai. Now it's Bombay, now it's Mumbai. It's called Tata Institute of Fundamental Research. The Homi Bhabha went there to establish nuclear, and from that came DAE and IAE and BRC, which is basically named after him. And also there is a kind of a thing that happened to him. He died in an aircraft accident near Switzerland. And I was reading that it looks like the CIA was behind it. That's what the final conclusion was. CIA, I think American embassy or consulate put a baggage in that airplane in the back, and I think that exploded. That's final conclusion I came to understand, because so Homi Bhabha was such a powerful in his visionary thing and the things that he was trying to do in India. He wanted to create nuclear bombs. He wants to develop nuclear energy. I think what I learned looking through, I don't know how much it is true, but it makes sense to me. Actually, a letter was found in 200 and somewhere, 10 or something, that linked that bag to the American diplomatic bag. That's how it came about. And there seems to be some interviews between a CIA agent that was involved with someone else. I cannot remember the name, but there is something to that effect. Well, my American colleagues are here listening to me, so, well, I hope I won't be in trouble when I go back. But anyway, that is, some of this information I think most of you don't know. I thought it's maybe helpful to understand some history behind. So I won't read this, but the first experiment was also conducted in Chicago by Fermi, and this is known as the Chicago pile. That was the first nuclear fission experiment done. I think it was December 2, 1942. And then, the World War II and the Japanese War, and I think America put in a lot of effort to creating the nuclear bomb at that time, and it was, I think, dropped on Hiroshima, I think August 8th of 1946, if I remember the dates correctly. So that is where the history, that is basically the nuclear technology, energy technology came from a bombing system. A bomb means it has a critical mass of uranium, and you have something called neutron multiplication factor. So this is a chain reaction. If it is uncontrolled chain reaction, the effective K is greater than 1, that's actually bomb. So what are the current light water reactors? They are nothing but we keep the K equal to 1. That means when the extra neutrons are generated during fission, some gets absorbed, lost. So you have control rods to maintain the criticality to be K is equal to 1. So these are basically controlled bombs. So that's what, but they are very safe. And the two accidents that you hear about is one in Chernobyl that was purposefully exploded because the operators that were trying, they are running experiments that is not meant for. And there were no people to control them, and they actually ran it. And the accident that you know currently, Fukushima, is also not because of the design of the accelerator. This is reactor. So they're supposed to put the water pumps above ground and the used fuel below ground. but they reversed that in the designs. So the water pumps were below, and when the tsunami came, they got submerged. If the water pumps were working, there would be none of this meltdown. So the nuclear technology is the safest and cleanest. There is nothing to worry about it. If you understand the history of what has happened. And United Nations has come out very clearly, if you want to eliminate the issues of pollution and all that, the clean energy required for the developing world has to come from nuclear. I mean, solar and wind can help, but if you want to really improve the health of the people, create the wealth, you cannot do with the solar and wind. The nuclear has to be part of it, is internationally recognized. And I know that there's problems in India with this, but this is not educated way. These are, there are vested interests, particularly in the US. These oil companies and gas companies, they do not want the nuclear systems to come up. They are willing to fund these NGOs to spread nasty stuff. I will give you an example. There is a Sierra Club in the United States. They are funded by Koch brothers. Who are Koch brothers? They make their money from oil. They do not want to see. These people are uneducated people. They feed them money, NGOs. They are getting money. They do whatever the money is given for them. So unfortunate that Indian masses are being dragged into by these NGOs that are funded by vested interests. It is very nasty. I think you youngsters, it's your duty to make sure, because you are science and technology people, you need to understand, and it's your job to educate. Well, I think I'm going off the rocker here. But anyway, this is very interesting talk. This is President Dwight Eisenhower. He gave a talk at the United Nations in New York. If I remember the dates, August 8, 1953, I think. The reason he has to do that is there is a lot of commotion in the United States at the time. This is my understanding. I was not there at the time anyway. I wasn't even born. So then the Russians are also trying to do this nuclear technology. There's so much money going on. He wanted to pacify the public and says, well, we can help the world by spreading the clean nuclear energy. That's what he addressed the United Nations. Well, what happened? Now nothing is happening in that. And this is a very interesting graph. Historically speaking, Homi Bhabha is on the right. So this was the first UN conference on atoms for peace. And unanimously, Homi Bhabha was elected as the chairman of this conference. So this is the type of person we have in India, and the visionary. And, well, what happened to him? He demised. But, he is also responsible for giving Vikram Sarabhai, he put Vikram Sarabhai in charge of the Indian space program, if I understand correctly. You can correct me if I'm wrong.
Both of them came down to Trivandrum to select their girls.
Yeah, I know that. All right, this is the 3-stage nuclear program. That was the vision of Homi Bhabha, why you need this. India doesn't have enough natural uranium. All the reactors that are running currently are based on enriched uranium light water reactors. I said they're controlled bombs in principle. We're trying to keep K is equal to 1. If it goes beyond that, they are a bomb. That meltdowns and all those things will happen. So we said for India, his vision was India needs to be clean energy center of the world from nuclear. That can only happen if you can convert. Thorium is like wet wood. It would not burn. It is not a fissile. It's a fertile material. So if you want to make it fissile material, you need to add additional neutron to it. So that is where the actual game comes in. That's why I call it's a neutron power. So we ignore Brahma, who is from my perspective, is neutron. So who is associated with neutron is Saraswati. Now what is happening in the scientific field? We build spallation neutron sources, they are called. They are high power proton accelerators. Proton is, Vishnu. And Vishnu gives a neutron by hitting a target. So that basically what is required to make this thorium from fertile to fissile. So to do that, according to this three-stage program, what we are doing here, we are using, so we are taking natural uranium. We do not want to enrich it. You don't need to do that. It is actually Canadian technology. It's called pressurized heavy water reactors. The idea here is you are producing plutonium as part of the chain. So going too far. Okay, so you take electricity, that's what I think there are, I don't know how many number you have, maybe 20 PHWRs running in India. These are based on Canadian design, but I think they tweaked them a little bit and made them better, I believe. And then you have depleted uranium. What does natural uranium has? It has only 0.7% of uranium-235 that is fissionable. So when you fission that 235, what is left? Majority of it is known as depleted uranium. That means uranium-238. So uranium-238 is not fissionable. It has to be odd number to be fissionable. So you take that depleted uranium, you take the plutonium, which is uranium-239, which is fissionable, and this is called fuel fast breeder. Okay, I am actually, when Indira Gandhi Research, what are they? It used to be called something else, Reactor Research Center, RRC Kalpakam. When they started, two of those guys worked with me. I was the first guy, and they didn't have facilities for cryogenics because you need a lot of that for some of the research, material science. So we worked together in this building. So I know a lot about what goes on there. And of course, they're running, at RRCAT, they are running an experimental fast breeder reactor, and they're also running the only uranium-233 reactor, very small size, kilowatt level, I think it's called Kamini, is also there. And you might have read that there is a new fast breeder reactor built, supposedly be running since 2010, I think. And then when your Mars thing went up, there is something in the United States press. Oh, well, India want to show off the world. They can not only go to Mars, but they will have the fast breeder reactor running at the same time. That is 2014, if I remember correctly. So that was what I read somewhere, I don't know. But now it is 2019. I have no clue what is happening there. I kept asking them. I have friends at the highest levels. They wouldn't answer. Nothing. Maybe, hopefully this year. So from that, what you do is you put thorium blankets around in this fast breeder reactor. So additional neutrons are added as a result of that. So it breeds uranium-233. So you take that uranium-233, and they already designed a advanced heavy water reactor. It's supposed to run with thorium. So this is the cycle, they call it closed cycle. So, but we spent about 55 years now. We are here, and then there was a conference, international conference on thorium energy that was hosted by BRC in 2015, and they have openly in international forum admitted that they need another 45 years to come to this. So in the current situation, I think there is an urgency. I mean, China is building, well, let's go here, one more, let me see. Okay, this is what is happening in 2014 according to Wall Street. So China is going to overtake the world by building all these reactors. So they built all the coal plants, and they polluted their environment, they realized it, and now they are going to switch off all that, they are actually implement all the nuclear. So where does USA? USA built by 100 reactors by 70s, and none after that. No reactors were built, and I think currently they are building 2 in Georgia, the state of Georgia, 2 reactors. I think they may be AP-1000, I believe, and they are cost overruns. So they are about $20 billion a reactor, somewhere there. So in the West, nuclear technology is basically cannot be implemented in the West because the costs are so high, it takes so long, and you have to take the loans to build them, and if it takes 10 years or more, you are paying for the loans. So they are not going to be economically viable. The only thing that is possible is only in Russia and China, and I don't know, India is building from Russians, and I think, yeah, they are, Kundana. Bought out, but where is the fuel coming? I thought that's, yeah, but that is, Russia, if they want to blackmail India, they say, well, we won't supply you. I put this question to Chidambaram, I met him here. Oh, yeah, we have nothing. We have nothing to worry about. So, but I think same reason, and they are trying to get from the United States with the agreement that the fuel will be supplied. But anyway, well, this is boiling water reactors, so I don't know. These are all the currently that are being built or in the process. These are the pressurized reactors. You can see mainly two of Indian origin, I think. AP, no, there's nothing here. No, not on this one. No, this is just to give you an idea where these things are being built, of what kind. Yeah, you can see HWR are supposed to have received international claim that they are very well designed and very safe. And then pressurized heavy water reactor there. This is the current uranium-based technology. So what is the problem with this? One, you need a big pressurized, high pressure, concrete domes that takes a long time to build. And then you have the spent fuel. As I said, only 0.7% of uranium-35 is fissionable. And then these pellets are in tubes, enclosed. Then there are reactants. There are things that in the system, strontium and other things, that will absorb neutrons. So they are not going to be effective. So you need to change the fuel every year or something like that. So the spent fuel that United States we have is 80,000 tons of spent fuel sitting at the reactor sites. It's a public concern. Why it should be a public concern? So the reason is here. So if you take the radioactivity of natural uranium is here, and the fission and activation products that come out in the reactor, their radioactivity goes up to 300,000 years to come down to the natural uranium level. So that means you need to protect this material for 300,000 years to prevent any health hazards. And also, this has a lot of plutonium in that. So in 1974, President Carter said, you cannot reprocess this, because if you reprocess, plutonium is available, people can steal it and make the bombs. So in the United States, reprocessing is not permitted. That's why we have 80,000 tons. Sitting very close to me, within 20 miles, there's a lot of spent fuel sitting near to my home. This is of concern to the community. That's why in the United States, the public is not really interested in this, but things are changing because Russia is now leading. Russia and China are supplying, as you have seen here. Maybe these are the reactors that are built by China around the world and Russia, but none from United States. So that is changing in the elected officials. The representatives and the senators are worried, and now they are actually introducing bills to bring nuclear technology to the forefront to develop that. And maybe I have somewhere to show that. Okay, so now I come to the thorium cycles. When I came in 2015, I actually got some funding, initial funding for a startup company in the United States. It's called Thorcon, thorium converter. And basically their plants looks like that. A gigawatt plant footprint of this design is this. It's all 180 millimeters, basically kind of a square. So it will be close to the seacoast. So these will be built in a shipyard, and their cost is so small compared to any other technology. It's cheaper than coal. let us see, this is how they are going to be built. So actually this is a shipyard. These reactors will be built like ships, and then they will be transported to the site, completely built. So that means very good quality control, and cost is the lowest possible. And there are quotes now from a North Korean company to this company to build this, about $1,000 per kilowatt. You don't need domes for this. I'll come to that. This technology. I mean, these are called molten salt reactors. So let me go back a little bit. Currently, things that are operational are all boiling water or light water reactors, because this water will be at a very high temperature and high pressure, so you need to have the domes if in case something happens. But there is other technology called molten salt reactors, which is also actually proven in Oak Ridge National Labs in the USA. And the reason the technology did not go that route is, if you go with that system, you cannot produce plutonium. So in 60s and 70s, the goal of US is to build as many weapons as possible. That means as much plutonium you can produce. That's one reason, but there may be other reasons. So that technology is actually the most safe, and it's room pressure, ambient pressure. So these systems are ambient pressure, and they are very high temperature. These are very high efficiency compared to the conventional reactors. They cannot be operated about 300 C. There are limitations. But these can operate up to 700 C. That means they can also be used to produce hydrogen, high temperature. So there are many advantages, but I think United States is stuck its head in the sand. It's not going to do anything. And I try to bring this technology to India. I spent 3 or 4 trips. I brought the groups here. We sat in Delhi trying to get to Prime Minister's office and all that. And well, I will not go into all the details of that. But anyway, so they have done all the calculations, and it's a proven design. The interesting part of that is the fuels in this system are very flexible depending on where you are. So eventually they will be able to even breeder, or you can best fuel utilization would be, this is called flip salt, that is fluorium, lithium salts, boron, yes, and this thorium you can load up to 82%, and then is uranium, and basically it's self-generated. But of course, these systems will not start there. You start initially with this, about thorium will be 0, but you breed something 82% here, and then you go up, and then they can be generating fuel at the end. This is a very versatile system, very cheap to build because the way the technology is developed. The guy who started this was a professor at MIT. He built 3 world's largest crude carriers, very cheap. So he wants to use that technology. Now everyone else is trying to follow this design. I see that in multiple other corporations trying to implement parts of this. So I tried to get this to India, and it was prevented. And now they have a contract with Indonesian government. They are going to build 3 gigawatt systems for Indonesia in the next 4 to 5 years. So this is going on. That's why I get all the details, because I got them the first investment. So I know what's going on. And this is the option. It could have been started right away. And of course, there is another option. That's what, let me look at the economics. So these are the details of the generators here coming. And this is the world design where the generator will be outside. But I think they have improved that. Everything is going to be, this is to compare in scale to current coal plants. The construction cost, why it will be low? Because its footprint is small, amount of materials used will be small, and they are highly quality controlled in the construction. So this is where it gives the costs, and you can look here. The coal at the present is 2.62 rupees per kilowatt hour, and which is, I think now you are able to get solar, but solar is not available all the time. It's intermittent, and well, you need a lot of land to create the same energy, whereas the footprint of a gigawatt plant you have seen is 180 meters square, and you cannot get any energy density comparable to this. And what happens here, you see here, Thorcon design that I just showed you is 1.74 rupees per kilowatt hour. Of course, this is the production cost. And I come to this, so India recognized and the world has recognized that it's easier to run these reactors below criticality. That means you do not need critical mass and they cannot become bombs. This is subcritical systems, but for them to work, continue the reactivity, nuclear reactivity, you need to add continuously neutrons to it.
Thank you very much. It takes before the tours and talk about these the role of technology in accomplishing the goals that we have been talking about. Okay, not just for the village, but going forward for India as a whole. So we have perspectives on different kinds of technologies, and we'll talk about it.
My point of view, and is there any opportunity for discussions or anyone have questions on it?
Are these safer than the normal nuclear plants?
Yes. These are ambient pressure, molten salt already, there is nothing to melt. Everything is molten already. Whereas the conventional stuff is solid metal oxide fuels, and basically they generate these gases that are encapsulated, that are poisonous to neutrons. And so as a result, either they have to move the fuel rods around or they have to load the fuels every year or every year and a half. These things can be continuously fed if required, and they are subcritical. So the other ones, as I said, in principle are controlled bombs. You have control rods to control the nuclear reactivity.
They would generate as much radiation as any other.
Yeah, but the thing I'm talking about, if you go through the thorium cycles, you do not have these minor actinides. You know, the graph I showed you, and the thorium spent fuel will become to natural uranium background radiation within 300 years, compared to 300,000 years on the other cycle. And by design, of course, even the other reactors are designed well, they are very well controlled. That's the reason why they are very expensive and it takes a long time to build. These things can be built in a factory and moved to the site and run, as I showed you. But they can be anchored in the sea. That's what is being planned. Actually, Russia has built one on the, they are moving to somewhere an island. So that is already happening. Russians are ahead of everyone.
If you look at it as a systems of systems approaches, how do you see an incorporation of the bio-waste, fuel, using waste to fuel, and like other smaller reactors to help the entire ecosystem within India? Is there models that have used like many different energy systems and storage systems?
No, waste fuel in the sense biofuel you are talking about?
Well, I believe a professor was speaking earlier about how you can change the waste, the 100 tons of waste produced into biofuels, but that's for transportation. But there's many other opportunities within the systems. I didn't know if you guys had talked about using multiple
Anything to do with the bio has a C in it, right? Mm-hmm. So if you believe in these guys saying CO2 and methane are causing the global warming, so we want to get rid of those things.
Oh, but we're producing waste.
Yeah.
Right? So we need
Yeah,
the waste is there.
well, you need to minimize that kind of waste. There are ways. If you put your head, I think you can come up with ideas that can reduce the waste.
These can be used. Sir, the thorium nuclear plant you are talking about, these can be used in aircraft carriers or in submarine as well? Like they used nuclear reactors to power the submarine and aircraft reactor.
I think if you move away from the linear accelerators that people are trying to build, and if you use small cyclotrons in principle, you can build micro reactors.
But is the radiation level is going to be less than the conventional one?
No, radiation level always will be there, except that these thorium-based systems do not have this long chain that you need to worry about.
So that will be more benefit to the submarine as well, because most of the submarine are caught by the radiation level itself. So they were also trying to look out for another option so that they cannot be caught by other submarines with the help of that radiation they are leaving in the ocean. So if thorium plant can do...
Well, I do not have all the details right now.
Okay.
Perspectives on the role of advanced technology really moving us forward.
Okay. Look, it's interesting if you look at resources, what China is doing. And I think it might be a good idea if India did things more like China does. And they are really going around the world trying to lock up some of the resources, like in Africa, in the South China Sea, and elsewhere, because they understand that if they're going to increase the level of standard of living of their population, which is large like India, they're going to have to increase their economy a lot, and this is going to take a lot of resources. So they're doing that. India has the same problem. Indeed, a theory in economics is called the conversion theory, and what that is that over time, the per capita income of the people of all nations will probably converge, which means per capita income in India and China will become similar to what it is in the United States and Europe. And if that happens, then the countries which have the biggest gross national product will be those nations with the largest population, which means by the end of this century, it may well be that the two major superpowers will be China and India. And under that scenario, they're both going to want to get a lot more resources than they currently are using. And so where are those going to come from? And China is very worried about that, which is why they're doing a lot of the things they are doing, but India doesn't seem to be following suit. So I think that's something that India should consider, the implications of that.
I don't know if I'm qualified to respond to that, but I thought I had a thought. I think India works more on soft power when compared to like acquiring hard resources around the world. So what we have done is to actually place a lot of Indians around the world. Okay, so and it's going to continue to happen for a long time. Simply because we have too many of them, and many of them are young, they are outgoing, and they are all going out from here. Despite the best brains going out, we are still growing very well, so we probably don't need them as well. Okay, so we can manage, and we will have the best brains everywhere else, and even, not necessarily the best brains, but also other kinds of people all over in other parts of the world, wherever we need people, right? I think roughly it's going to be like one in 4 person in the world is going to be an Indian, and you need them in all kinds of places. So in about 20-30 years, you will find us everywhere. So we will be like the cockroaches, right? And that's going to be much worse than what China is doing.
Well, I don't know. I don't know whether being called a cockroach is a compliment or not. But let me just move away from this discussion about human power and soft power and hard power. I do agree with Mark that the Chinese have been very clever about buying up resources. But I wanted to talk a little bit about technologies, and this is something, in IIT, I would like to emphasize the fact that India has fallen behind in several critical technologies. And it's a matter of grave national concern. And I would blame both the educational institutions and the large corporations in this country which have severely underinvested in R&D. If you look at the big companies, I don't have the numbers, but they probably spend close to 0% of their sales revenue on research. In Silicon Valley, the average company spends about 13 or so % of their revenue. So therefore, it's a large number. And that's the reason they've been able to churn out discovery after discovery. If you look at India, there is something that I've been extremely unhappy about. We had great researchers, some of whom you would have heard of, such as C.V. Raman, Srinivasa Ramanujan, J.C. Bose, somebody referred to him yesterday, S.N. Bose, Subramaniam Chandrasekhar. What's tragic is that these people all flourished before independence. After independence, there has not been a single, and I emphasize that, a single world-class invention or discovery that was done by Indians in India. Yes, they've been done by Indians abroad. For example, Hargobind Khorana won a Nobel Prize, but he was an American. And Subramaniam Chandrasekhar also won a Nobel Prize, but he was an American, Venki Ramakrishnan, right? So what's happening to all these brains? They're basically being degraded in India. That's a major problem. Now, to take that one step further, I wrote an article about 3 years ago saying that there are 3 significant technologies that will have a massive impact on life as we go forward. And I focused on AI/ML, artificial intelligence and machine learning. Secondly, on CRISPR, genetic or gene editing. And the third was blockchain. Now, if you look around, and there are other candidates, but I just picked these 3 as the most important. If you look around, I would say that India has a very poor presence in research done in any of these 3. Okay? Whereas if you look at China, they have, despite their language handicap, one thinks that, Mandarin must be a handicap compared to English, but it turns out it's not. They're now churning out more advanced research papers in AI than the Americans are. And furthermore, every American paper is translated into Chinese within like 5 days, and not vice versa. So they're building up tremendous expertise in AI in essentially code language that nobody else can read, right? And you've seen the implementations of that. AI, you can use it for good and for bad. And if you look at the bad that they're using it for, it's this surveillance economy that they've built up, right? They do facial recognition so that they can create what they call a social score on you. And this basically classifies you into good person, bad person, etc., so that eventually you will one fine day show up at a railway station and you try to get into your train. There's, sorry, you can't get into this train because your social score is too low. Or your kids cannot go to school. Why? Because your dad's social score is too low. They're actually implementing that. Now, you could say that's fine. The Chinese are doing it to themselves. But they're going to do it to us, incidentally. Why? Because we've been extremely lax about retaining our personal data. If you look around, many of you, how many of you use Paytm? Show of hands. Do you know all that data is going to Alibaba? Did you know that? Alibaba owns 70% of Paytm. I can guarantee that all your data is with Alibaba. Okay? There's another entity called Sibyl. Have you heard of Sibyl? It's a credit agency. Who owns Sibyl? TransUnion, an American credit agency. Therefore, all your data is in the hands of Americans and Chinese. And I view the Americans, and I'm not saying this because we've got some Americans here, as more benign than the Chinese, okay? Imagine, no, I honestly believe it's true. Imagine one fine day, Alibaba and Paytm impose their social credit score on you. And you're going to buy, I don't know, an air conditioner or something. They're like, no, you can't have an air conditioner because your credit score is low. Right? So we have done a terrible job of managing our data, which is, it's a cliche. They say that data is the new oil. In the 20th century, the world was run by oil countries, right? Saudi Arabia, OPEC, etc. Now they say data. And we have wasted all our data. And I don't know why they're still farting around in this country about regulations that suggest that India will insist on its data being retained in India. Just retained, with access for foreign companies. Even that's being fought tooth and nail by Facebook and Google and whatnot, right? So we have really screwed up, in my opinion, on AI. Second, we're totally absent in CRISPR, right? Whereas the Chinese are now creating, genetically modified babies, which is a bit much, but they've done it a couple of times. If you look at blockchain, I think there are a bunch of things that are being done in blockchain in India. For example, I know some companies that are using blockchain to manage your food supply chain so that you know who handles your food. Because I think it's becoming a major problem for urban Indians that your fish or meat is contaminated with formalin and with ammonia and stuff like that. So you'd like to know who's handling your food and exactly where the formalin is being put in so that you can stop them from doing it the next time. And also other things like financial blockchains and so forth. But what I'm trying to point out is that there's a whole slew of new technologies out there, and we're under-investing in them, both as institutions and to a certain extent as startups. Because if you look at the successful startup stories in India, and I'm going to talk about this tomorrow a little bit as well, so this is sort of a sneak preview. They tend to be entities that have copied business models. Okay, so you have Amazon, and then Flipkart copies their business model. I'm not saying that's wrong. I think it's a very good idea on their part to have come up with a great business model and copied it for Indian environmental conditions. Similarly, you've got Indigo, which copied the Southwest, what is it? Southwest Air, is it? Southwest Airlines business model. That's brilliant. Where are the product companies? Okay, where is the Alibaba? Where is the Baidu? Where is the Tencent? Where is the Google? The only company that I can see today that has an inkling about creating a platform, unfortunately, is Reliance Jio. Reliance Jio has an idea to create a payments mechanism, to create an e-commerce plus physical commerce mechanism. And I'm like, good luck to them. Everybody thinks Reliance is too influential in government and they can get things done. But we need a platform. And how come, nobody else thought about it, right? Why did Flipkart end up being sold off to somebody? Why did Reva, the electric car guys, they were ahead of Elon Musk and Tesla, for heaven's sake. 10 years ago, Revas were running around. What happened to them, right? So we have Mahindra bought them, but Mahindra has done nothing with them, really. So we have a big problem. We're not abreast of technology. Now, I was really impressed to hear the stuff that was being done in your lab and so forth. So maybe I'm being too pessimistic, but on average, some of the major cash generating and value creating technologies that have made Silicon Valley, for example, so powerful. Today, when Facebook is talking about their pseudo-currency called Libra, it appears as though they're more powerful than most national governments. Literally. They can create a currency that's supra-government. Who gave them that power? It's the data that they have collected from, I don't know, 2 billion users, right? So where is India's Facebook? Where is India's, Google, etc.? So policy has been, I would say, myopic, right? And we've also been, in my opinion, too complacent because we think we're a software superpower. Nonsense. What we're doing, I worked in software for a long time. What Indians do in software is low-level maintenance. And these jobs will disappear through AI, machine learning, and RPA, robotics process automation. So our software competency is like, you may remember medical transcription. You guys are too young for that. That used to be a growth industry because what you did was you took these scribbles from, well, not scribbles, you took these voice records from doctors in the US and you typed it in. And that was a growth industry in India for a while and it just disappeared overnight because machine voice recognition became a viable technology. So software services, I think, it had its day in the sun, but that's over. Software products and software platforms. A platform is an entity that connects 2 or more parties, right? So for example, PayPal is a platform or Airbnb is a platform, right? Those are the things, at least today, that are most powerful, and we have no platforms. That's why I'm hoping Reliance Jio really makes it. Anyway, I'll stop my tirade now and let others speak.
I think you're a bit pessimistic. Look, historically, the leader with regards to technology in the world is the country which has the highest GNP with a lag. If you become the country with the largest GNP, you won't necessarily be the leader for a few years, but eventually you do. And that's because what counts with regards to a lot of this leadership and technology is how much money you invest in R&D. And if you're the biggest economy, then you can invest more money in R&D than smaller economies. What's happening is that China is, again, because of this convergence thing, is catching up with the United States as far as its total GNP, its total size of its economy, which will probably surpass the United States sometime in the 2020s. However, India is growing faster than China. It's now growing the fastest major economy in the world. And if you're sort of behind, it's easier to grow, again, because of the convergence theory. So eventually India will tend to catch up with China. And when that happens, India will become much more competitive with China on this R&D stuff. In the meantime, you probably can't compete with China across the board, but you'll have to pick the items where you want to try to compete because they're going to put a lot more money into R&D than India can afford. You can also try to make an alliance on R&D with the United States, which I think would be quite interesting because a combination of the United States and India in the R&D area might be capable of competing with China until such time as India becomes an economy which is the size of China and maybe even larger.
Rajiv, I have to tell you that a lot of things that you've actually pointed out have already been, out in the open, and all these things have been discussed, right? So, for example, you start with, all the CV Raman, blah, 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 and then you say nobody else. Down here, that's been discussed. I think you should look up Gangan Pratap, who has, considered all these things and then put out current science articles and stuff. So his answer is, until up to the independence, it was all about individual scientists who could actually do whatever they wanted, but subsequently they were all drafted towards making the Atomic Energy Agency, the Space Research Organization, and all of those things, and they have really flourished, right? So Homi Bhabha, Vikram Sarabhai, all those people actually, if they were not hamstrung into developing these organizations, they would have probably got some Nobel Prize or something, like their predecessors did about a couple of decades before. But they had this huge responsibility of a budding developing country to come up with these organizations, which are in some sense unparalleled around the world. Okay, I mean, with the kind of shoestring budget that ISRO is still working on when compared to NASA, right? I think we are doing fabulous, right? So how did we get there? And that's not so easy. So we went into a planned economy, and we had these kinds of plans which essentially said, I think we will bother about these rather than the Nobel Prizes. Maybe somebody did a conscious decision, I don't know, but what we are doing is this. The second reason I personally think we don't have Nobel Prizes is because we have what is called as the JEE. And this was actually articulated by Venki Ramakrishnan. If he had cleared the JEE, he wouldn't have actually got the Nobel Prize. Okay? Every year, and this year, my daughter has gone through this. She has actually made a cartoon that made me cry. Right? Every year, there are students from age group of about 14 to 17. They are actually going through this entire rigmarole. When they are turning adolescent, they need to actually start smelling the roses. They need to be very creative. They're all put with the best brains in the country are actually put through this rigmarole of a JEE, right? For which the IITs are singularly responsible. And it's a huge crime. It's kind of like the tripos of the Cambridge that happened the previous century. And the reason why, it's not even the reason, it's an excuse. The excuse we are actually going through this is because there is no other method. But please, for heaven's sakes, understand the problem, right? You are stifling young brains into just doing some rote problem solving and not really asking them to think about physics and chemistry and so on in a much more creative manner. And how do you expect Nobel Prizes will come? Right? And then we think that it's because we have a huge population. No, we are actually a damn Brahminical society. That's basically, we want to actually put everybody in some kind of a neo-Brahminical order, where somebody who gets into IIT is like more superior, the guy who is not in IIT is less superior, and so on. And the private colleges are not actually changing the matter at all. Right? I mean, you have like so much privatization of education that has happened. Not one private college has come anywhere close to an IIT in terms of any standard, proving the point that IITs are actually superior. And this whole damn thing just keeps going on. What nonsense are we talking about? Right? So we have the money, so population is not an excuse anymore. Nobody wants to bell the cat. This is basically the problem. Right? Young people should actually be allowed to flourish, and that is not happening in this country. That's where the problem is. Finally, I've thought through these things so many more times, right? You go through any number of things, you take artificial intelligence or papers. But by the way, so 2007 to 2012 time frame, in a 5-year time period, India actually moved from 15th in the number of publications to 4th in the number of publications after China, US, and UK. Right? So we did a marvelous job just trying to climb up the publication ladder, simple. Now we will start thinking about quality, right? So there is a 5,000 crore investment that's being made by the government on cyber physical systems now. And they are trying to set up lots of groups. There are AI chairs that are being positioned over here and so on. So maybe, I don't know, they are not enough impactful and so on. One of the things that I still remember Prime Minister Modi mentioned, which actually got drowned in a lot of other sloganeering that happened by him as well as a lot of other people, is these 3 words which I think really hit me hard. Skill, scale, and speed, which is what China was really good at. Right? We just can't think scale at all. If I'm actually, I mean, look at Saravana Bhavan, man. They can actually make masala dosas everywhere in the world for the same quality, right? Why can't I produce an IITian like that from everybody around here, right? That is an engineering problem that we have to solve. We are not really thinking scale for the kind of people that we have, the number of people that we have. And we have to do this very fast. The speed is very important too. Right? So these are all things that we just don't think about. We are way too Brahminical. We just want very, very, what do you call what is the word for it? Like, no, it's like graded, hierarchical, whatever. Right? So we want to have some, still, that word is eluding me. No, no, we always want to actually give excellence something like put it at a pedestal. And then we want only a few people to actually excel so that we can now say everybody else is like, beneath that. That's very, very wrong. We have to take an ordinary person into a college and make him superior. Rather, IITs are actually taking the best people and then, I mean, it's very wrong.
If I can respond to the points
Wait,
that you
wait,
made.
wait, wait,
Can I finish?
one final point. After considering everything, what I have come to think is actually extremely racial. Indians have a big problem. We have something that I have coined a phrase called brown curse. We think the white man is superior. Whatever comes from the West is actually the best, right? We just don't have any trust among ourselves. This is a huge problem. Right from the day I came back from the United States, I've always felt that we just don't trust each other. Businessmen won't trust academics. Citizens don't trust their damn government to pay damn taxes, man. Right? We don't pay taxes and we want everything to happen by the government. And the government's, and it's a democracy, so the politicians are actually selling dreams. Right? So all these things are huge nonsense going on around here. We just don't trust each other to do anything. Investors don't trust startups. Businessmen won't trust academics to do the research that you're talking about. Academics will not do, industry quality research. Nothing happens. Right? Because we are like, we are on this utopian pedestal. Academics are on a utopian pedestal. Right? They will not do anything industry related. Right? And the industry guys will say, okay, why do I actually go to this guy? I will actually go get foreign technology. Why? I have come to the conclusion that your nuclear weapons, ballistic missiles, and launch vehicles are the only three things where India has excelled simply because that technology is denied from abroad. Okay? All other technology, fighter aircraft, jet engines, anything that you take, right? You can go get it off the shelf outside. So why would you want to actually do it here? And it makes business sense to actually go and get it from outside. So we can actually be slaves, technological slaves forever. It suits us fine because we are all like brown slaves. That's what we are.
Okay, I don't know about the brown slaves part, but I want to respond to you on Gangan Pratap. Narayan and I sat down with Gangan Pratap and had a long conversation. And he's not at all positive about the research that's being done in India at this time. He's extremely negative. I actually quoted from his current science paper where he says that there are only out of 15 major areas, there are only 2 or 3 in which India even has a presence. So that buttresses my point that we're doing, very poorly in R&D. Going back to the other points that you made, if you look at China and Japan, both of those countries have extremely tough, very similar exams. And if you don't get through those exams in Japan, your life is ruined. So they have exam hell. They got lots of children who, kill themselves. So I think this, it's a scarcity thing. Everybody wants to get into Tokyo University or Peking University or something like that. I don't think it's all that different here. Okay? Now, on the other hand, I agree with you wholeheartedly on one thing, which is the educational structure here. We have a structure that is imposed on us by the British. They brought in Western education in the whatever time, from 1850s or something, which was meant for the first industrial revolution. What does the first industrial revolution want? It wants large numbers of literate people who will obey orders and not think. You don't think, please. We will think for you. We'll tell you what to do. You just do it. And that education has continued. So until we reach a point where creativity and thinking out of the box, solving real problems, that gets some premium in India. I agree with you wholeheartedly. The rote, the quota and whatever other cramming academy kinds of things that all our kids go through is an absolute waste of energy, time, and money. But it's much deeper than that. If we have an educational system where you tell children right from the beginning, be creative, come up with your ideas. And in fact, oddly enough, if those of you who haven't heard of Dharampal, I'm going to be quoting from him a couple of times, I would strongly recommend you go read up Dharampal's books, which are available freely on the internet. He's written 5 books based on original British documentation. When the British first came to India in the 1700s, they weren't looking down on us. They were full of wonder at all the things that they saw here. And the amount of disinformation that we have collected, and you talked about Brahminical and so forth, which is part of that disinformation. It turns out, according to Dharampal, that our education system, I'm not a Brahmin, by the way, so I have no, dog in that game. The education system, in actuality, had wait, let me finish.
It's not the caste, it's the attitude.
Yeah, I'm saying it's related, okay? And so the education system here was extremely egalitarian. So if you look at Madras presidency, there were far more people of lower jatis who were being educated than upper jatis and so forth. So that education system was actually fairly good. The second part of it is that we have this, in addition to this rote learning, we have this standardized mass learning, which is oriented at the middle of the road student. If you're either a brilliant student or a slow student, there's nothing for you. This is where I think AI can become extremely useful, because if you crunch a lot of data, you can figure out a customized learning plan for the child, which incidentally is something that's applicable to medicine as well. My biggest complaint about allopathy is that they give the same drug to everybody and expect that it'll cure you, but it may not cure you because your body is different, right? Whereas Ayurveda tries to do customized medicine. So similarly, if we can do customized education, we may end up finding a lot more brilliant outcomes coming from that. So yeah, those are the, I don't remember what else you said I wanted to respond to, so I'll...
Okay, so it's ironical that you are stealing my thunder. Man, that's exactly what I'm going to dwell on tomorrow, but nevertheless, I share this gentleman's agony, and if I may share with you that part of my persona is more animated, which will come to the fore tomorrow. But the idea is that what you just said all lends to the fact that there is a lack of creating a scientific temper. And that is percolated down from the top to the bottom. Now, all you gentlemen, very illustrious on the dais, have all talked about the problem. Okay? And we've all talked about this is what government should do. What the hell are you and I doing? Are we doing something? Are we doing anything to alleviate the pain points? And that's what is important. So we can all blabber all day long about what we should do and what the government should do and all that. I will please urge what I can do. How do I contribute towards solving this crisis? I want to do some soul searching, all right? Please.
So I will give you my example for here. Now, when I came here, my scholarship was funded by DST to develop cryogenic technology in the United States, in India. So I came, I start off to do the low temperature physics. I came here for that purpose, right before I came here. And so I got selected because Professor Srinivasan heard that there's a kid here who wanted to do low temperature physics. I was selected. And he's such a great man, and he gave full freedom. He tried to put me in his mold gave me a research problem, which is nothing to do with this project I am hired for. So I said, no, I will not do that. My project, I will do what is relevant for the technical solutions in the field of cryogenics. He said, okay, bye. That's fine. You're on your own. And I finished my thesis in 3 years, but anyway, in the meantime, I was sent to Germany because the German professor wanted me there, and I did some work there, and that's what I used for my thesis here. But the point I'm saying is the educational system, the way we develop the graduate students, we should let them expand their horizons on their own. You should not bottle them into things to do. I think that's very important. I don't see that type of thing happening. They are being spoon-fed at the graduate level. That's not what is required if you want them to grow, to help out. And also, I did actually industrial projects when I was here. I used to build systems and even certify the tiles for the theaters. I got money and we all went out for things. I was helping the hospitals to repair their systems in the general hospital. I went and repaired with kids. Professor Srinivasan was so nice that, yeah, let's go and help. We did all this kind of stuff to help around. And I don't know what the situation now is, but I think even in the United States, the students are fed to do certain things. I don't think they are given freedom to do it.
I have a few comments, and I think we need to close if people are going on those tours, which is all right if you want to stay and chat with me, because I have no intention of going on any tour. But he probably has to go out. A couple of things to point out. One is that since they don't give out Nobel Prizes in engineering, and they didn't give one to me, I think this whole Nobel Prize business is wrong emphasis. No, seriously, I think people in India should, to give broad advice and unsolicited advice, people should please question this notion of going by, this person won this award. These awards are given for a reason, and merit is, I'm sure, a part of it, but only a part of it. Okay, if you want to win a Nobel Prize, you should go and work in a group that is large and has immense clout and will write your nominations for these things. Well, how do you think I've thought about this. How do they select somebody to win a Nobel Prize? Do they sit there and look up Google and see who is it that has done wonderful work? Or do they look at 5 or 6 nomination packages that come in and do a horse trading and closed door, whatever it is, and somebody comes up with it? Which do you think is happening? Think about that. Okay? So this notion that because somebody got a prize, they are the best at something is ridiculous. Okay, so that is the first thing I would say. Try to get your students, at least that's the only people we can even hope to influence, away from this notion that the purpose in life is to win some prize. Okay, so that is one thing that I found. The second on the JEE, I would not blame the JEE. It's a very good exam. What has happened there is that people, I used to have a lab mate, well, he was actually a student of mine, but he used to make fun of his junior student who was a techno geek, and he said, he's saying, my dad bought me my first 3-component laser Doppler velocimeter age 3. People in India start preparing for the joint entrance exam of the IIT at age 3, something like that. That is what destroys childhood. I don't have a solution for this. You have a huge tutorial business all over, and there are superstar teachers who apparently have a stellar record in coaching people through the JEE.
Oh, they make a lot of money.
They make a lot of money. More. Oh, yeah. I can't really comment on that because I'm kind of an accidental IIT entrant. Because I got a book on JEE, whatever. I had no idea. When I finally got into the IIT, all my mother's friends came and sympathized with her, saying, oh, poor Narayanan, I thought he was a good student. He only got into the ITI, couldn't get into the engineering colleges. So that was the level of knowledge there. And literally, when we went to the, we all said, oh, this is exam, why don't we go take it? And we went there, there was like 10 of us or 15 of us.
All that is old story.
Then, half an hour later, there were only 2 people left there. So, I know, this is a very different time. But I think before you throw the JEE out, you should find a way to sabotage this tutorial business. And I think the only way to do it is to be smarter than they are and point out that those who went into the tutorials had a poor record and we were able to find others. See, I actually had one experience. I was being considered for some position somewhere in a university in India. And I said, what would you do about it? I said, look, you want to increase your ranking, go find the JEE, the JEE rankings, okay? And look at the economics background of every single one of the top so many people. Find the ones who have come from a poor family background, give them 5 years, full tuition, full whatever it is, get them into your university, and they will, of course, the fact of associating with them. People said, you don't know what you're talking about, which was right. They said, look, there are no poor people in the top 20,000. Right? How can this be? When I went to school, I had classmates who had no shoes. I can mention some names here, and then now they are university professors and doing extremely well. But that is apparently not the situation anymore, because if you don't have the money to send your kid to tuition classes, they're not going to make it into the first 20,000. So these are the difficulties that maybe should be, this is a system rot that is set in. That should be eliminated. Otherwise, the JEE is a very good. So that is one. So anyway, I think that's probably all I want to say.
I think that lady wants to ask a question,
Yeah,
but
okay.
let me just relate this particular anecdote that really was a big slap on my face. I was visiting University of Darmstadt, where my host was transitioning from being a, what do you call, they can't become a professor until they are very late in their career, and then he was actually now looking for professor's position. In Darmstadt, he was getting an offer, and in Aachen, he was getting an offer. He was actually trying to think about where to go. So we had this lunch, and so I'm meeting him for the first time or thereabouts, and then so I have to actually now try to pep up my own record. So I said, like, I'm from IIT, and I was an IITian myself, and it's so hard to get into IIT, blah, blah, blah. He just listened to it for a while, and then he said, oh, in that case, you're going to have great difficulty getting a PhD student. It was like a huge slap in my face. I asked him, how did you figure that? He said, well, you're not training enough people to actually stay in the country and work with you, right? And I asked him, then what does a German do, right? What does the typical German do? How do they select, how do they decide which college to go? He said, well, whichever is the nearest to you, we will actually go there, right? So don't you have like a ranking of TUs and so on? Yeah, you know, the biggest, the worst and the best TU are about 20% apart. So it doesn't matter. So he tells me that he was choosing between Darmstadt and Aachen. He is a mechanical engineering professor. He had to teach 600 people coming into TU Darmstadt mechanical engineering every year. If he went to Aachen, he has to teach 1,800 people. Here, yes, here in IIT Madras, we are taking mechanical engineering, 180 people, right? There are 9 TUs in Germany. Germany, area-wise, is of the order of like about Andhra Pradesh or thereabouts, right? We have 23 IITs for all of India, right? And the newest IITs are taking like on the whole 120 people. We just don't know scale. We just can't think scale at all for the kind of population that we have. We don't know how to multiply. We don't have to grow. We don't want to because we have this elitist attitude, is what I think. This is a problem.
Can I make just one comment? I remembered what you were saying about slavishness to white people. Do you know why? English. Yeah. Okay? English is the problem. We got to get away from English. And you asked me, I'm sorry, Amitabh? You asked me what I'm personally doing? No, I'm telling you, I mean, I took that personally. What I'm doing is, well, because I have a good answer. That's why I took it personally. Okay, that's good. We'll hear you tomorrow. But what I'm trying to do is I'm trying to encourage an entity to invest in machine translation in real time so that all the MOOCs that are out there in English you can listen to in your own language so you don't get handicapped by English. So I'm trying to get that going through some government. It is a government entity which has the funds. So if that happens, sooner or later, we'll all be comfortably learning, you know, in our, and somebody mentioned yesterday, Prabhat Ranjan, I think, who said that you absorb much more in your mother tongue than an alien tongue. And one last point, see, we think in English. There was a famous autobiography by a gentleman named, I forgot his name. The autobiography is titled Roses in December, because that's so rare in Britain. We have roses in December in India. It makes no sense whatsoever. So we have been sort of brainwashed, and that's part of the reason why we do that.
Yeah, I put my money where my mouth is, and you'll get to know it tomorrow.
I think I can see the heated understanding of the JE. A small comment from my side is that I think the JE has been a good system, except this multiple choice, I think, has just probably only thing. Now that we have some new two-tier system, if we can go back to this actual problem solving, which is what I think IITs originally started with, and you know, you get marks even if you did not do the problem correctly, but you had the steps right, which is what I think I went through. I went through the hard way, not because I'm an IIT and I'm saying that, but that was an immense learning, and that's where probably we need to go look at whether those things can be brought back in some form, because that would bring back the strength of JEE back into the system.
Can do all of that, but we just have to make sure that every citizen has access to good quality education. That's the fundamental thing that we should be looking for. That lady.
So like the thing about the IIT thing, so yeah, I'm not from IIT. So my college is so-called top 10 colleges of Karnataka. But then actually if you come and see our laboratories, it is in a horrible condition. So most of our machines are age old, 30 years old, 40 years old. So when you say that you should learn it practically, you need to make papers, you need to learn your technology right. Without the right facilities, it's really hard. And you can easily say that, okay, that's your college problem, your college has to invest in the machines. But that's not happening because it's all about profit. Every school, every college today is only looking for making as much profit as possible. It's a business now. It's no more like make a good student or make a right engineer, right? So it's very easy when like companies come and invest in IITs and they make advanced technologies in IITs. The number of students using your technologies is the 10,000 students who make it to IITs. And it's so hard for us to like actually come up to IITs or like work with the advanced technologies. It's really hard because we need to maintain that 85% attendance and stupid stuff about 8 GPA and stuff, because eventually with a bad resume like ours, which is not qualified enough to like take us to outside universities to take an MTech or a further degree, what will we do? We will actually sit down for placements. And what will placements ask? Like, what will the companies ask us for? The first thing is, you need to have enough GPA, right? That enough GPA, we are going to mug up the answers. We are going to be like, these stupid people are going to be like, what do you say, a group of sheep following the same thing, right? It's easy like to say that, okay, you students have this easy way out. You just want to...
Got you, Diksha.
Yeah.
Let me cut you in and say something. The education system that we have today is devised in the 20th century. The Western, of course, British and all those things like much more before. But the entire current Western education system that we are following in India is meant for you to actually go sit for jobs in large corporations and companies,
exactly.
right, and governments, right. In the 21st century, you have whatever he is talking about, right, MOOCs and all of that. You learn by yourself, and then you actually have your own startup. Don't actually go for placements at all. That's what I would say.
Yes, sir. But there are certain things where like you need to have that right kind of approach or that right kind of technology or the right people around, which is very hard for us. And it's not just 1 lakh students that are coming out every year. There are so many lakhs, right? I mean, how do we get that kind of people to meet or that kind of technology? So, like how we all say that the whole structure is there is a huge flaw in the whole structure. That's very much true, but there is a lot of blame even on the student side, but I don't think that is like completely
As he was saying, right? So don't blame everybody else. Just look in the mirror, start thinking about what you can do about it. That's it. Yeah.
I think in the present, the skill development program is at the central government. They can include scientific skill development. That also can be included, not for the economic development. It is meant to develop scientific skills in the people. We must have separate projects at the central government level that we can implement. And it is only the present short-term solution for this particular solution, because each student requires first-hand experience. Otherwise, no creativity will come up.
Take the solutions to that people actually. They will sit in the office and then they will sit in the AC office. They will not. They will not.
Thank you very much. I think you can continue this discussion in this lab.